All right, let's just dive right in. We're going to put you in the hot seat. Imagine this. You've made it to the final round. The only thing standing between you and that dream job is a technical interview. Let's do this. The question seems so simple, right? But your answer is going to reveal everything. How you think, how you solve problems, and just how deep your knowledge really goes. Your heart might be pounding a little, but don't worry. We're going to get you through this. So here's what we're going to do. We are going to simulate that interview right here, right now. I'll be your interviewer, and by the time we're done, you'll have a complete playbook for not just answering the question, but for totally impressing the person on the other side of that table. Okay, let's get started. As your interviewer, I want to see how you build up your thinking. We're not going to jump straight to the most complicated, mind-bending solution. No, we're going to start with the basics to build a really solid foundation. This is a super common starting point. And listen, they're not trying to trick you with this. They're just checking to see if you know the fundamentals. So take a breath. How would you explain it? You'd say something like this. You take two numbers right next to each other, and if they're in the wrong order, you just swap them. You do this again and again and again, and with each full pass through the list, the biggest values kind of bubble up to the end. It's simple, it's intuitive, and it's a perfect place to start. Then you'd get up and sketch out the code on the whiteboard. So let's look at this. You've got your outer loop, which is basically managing how many passes you make. And then the inner loop is doing the real work, the comparing and the swapping. But here's the pro move you've got to mention, this no swap variable. See how it's set to true at the start of a pass? If that inner loop finishes a full run without making a single swap, what does that mean? It means the list is already sorted, so we can just return and stop early. Mentioning that little optimization shows you're already thinking about efficiency. And that leads right into the next question, which is always about performance. Thanks to that no swap check, the absolute best case scenario is O of n, which is just one quick pass to confirm everything's already in order. But on average, and in the worst case, you're looking at O of n squared. And for any decent-sized data set, that is painfully slow, all because of those nested loops. The interviewer nods and says, good. What's another simple approach? You could bring up selection sort. Now, the idea here is totally different. With each pass, you scan the entire unsorted part of the list to find the one absolute smallest element, and then you put it right at the beginning of that unsorted section. And when you look at the code, you can see exactly how that works. The outer loop just moves the boundary of our sorted section forward, one element at a time. The inner loop's only job is to go hunting for the index of that minimum value. Once it finds it, boom, a single swap puts it where it belongs. The key thing to point out here is that it always has to run through those nested loops, no matter what the list looks like. So its time complexity is O of n squared all the time, best, average, and worst case. It's predictable, but predictably slow. Okay, you've proven you know the basics. Now the interviewer leans in. Both of those are O of n squared. For a large data set, that's not going to work. Can we do better? This is your moment to shine. You'd confidently say, absolutely. We can use much more efficient algorithms like merge sort or quick sort. And these two really represent the powerful high-performance strategies. Merge sort is all about divide and conquer. Just break the problem down into tiny, easy-to-solve pieces. Quick sort, on the other hand, is about partitioning, intelligently rearranging the whole list around one special element. Let's start with quick sort. You'd explain that it's a recursive algorithm. The real magic all happens inside a helper function called partition. What that function does is it picks an element to be the pivot, and then it shuffles everything around to put that pivot in its final correct sorted position. Everything smaller goes to its left, everything bigger goes to its right. Then, as you see in the code, you just call quicksort again on those two smaller sublists. And why is this one so popular? Because on average, its time complexity is an excellent O of n, log n, but you also have to mention the trade-off. In the worst case, like if the list is already sorted and you pick a really bad pivot, it can actually slow down to O of n squared. Knowing that little detail shows a much deeper level of understanding. So what about that other one, merge sort? Well, it takes a totally different path. It just keeps splitting the list in half over and over until all you have left is a bunch of tiny lists with only one element each. And hey, a list with one item is already sorted, right? Then it carefully merges those little sorted lists back together into bigger sorted lists until you're back to one final perfectly sorted list. Its biggest advantage is a guaranteed O(n) log n time complexity no matter what. The catch?
It needs extra memory, space, to do that merging. The interviewer is impressed. You clearly know the general purpose workhorses. So now comes the curveball. This is designed to test how broad your knowledge is. They're looking for specialist tools, not just the couple of hammers. They might ask a question just like this. Something like, okay, what if you're sorting the ages of everyone in a company? You know for a fact that all the numbers are going to be between, say, 18 and 70. This is a huge hint that a normal comparison-based sort might not be the smartest choice. This is your chance to bring up something special, a non-comparison algorithm like counting sort. You'd explain that instead of comparing elements to each other, you just create a new count array and use it to tally up how many times each number appears. Then you can just build the final sorted list based on those counts. It is unbelievably fast, often linear time, but it only works in these very specific situations. Mentioning it shows that you think about the data itself, not just the algorithm in a vacuum.
All right, we are in the home stretch of this interview. You've shown breadth, you've shown depth. Now it's time to bring it all together for the final analysis. This is the final boss question, and it's not about picking one winner. It's about explaining the trade-offs. This is where you prove you're not just reciting facts from a textbook, but that you can actually make smart engineering decisions. So you'd lay it all out, comparing them on the things that matter. You've got bubble and selection sort. They're simple. They don't use much memory, but they're slow, squared. Then you have the two heavyweights. Quick sort is usually faster in the real world and uses less memory, which makes it a fantastic default choice. But if you absolutely positively cannot risk that squared worst case scenario, or if you have plenty of memory and you need a stable sort, merge sort's predictable, guaranteed log n performance is the safer, more reliable bet. You've laid out all the options, the performance, the trade-offs. Now it's time to deliver your final confident conclusion. This is the mic drop answer. It shows maturity and practical wisdom. It proves you're not just a coder. You are a problem solver who understands that context is everything. The best algorithm is simply the one that best fits the specific problem you're facing. So to recap the game plan for your real interview, start simple to build your foundation, know the critical differences between quicksort and merge sort inside and out, always talk about the trade-offs between time and space, and have a specialist algorithm like counting sort in your back pocket to show you've really done your homework. And that's how you ace the sorting question. You've got the job. But just remember, sorting is rarely the end goal. It's usually just the very first step to unlocking some deeper insight from the data. The real question is, once it's all organized, what story will you make it tell?